Okay, so we're going to talk about the first derivative test and its applications to where our function is increasing or decreasing. Okay, so this is our f prime. If we know things about f prime, right, that's your derivative. If we know things about f prime, what does that imply, or what can that tell us about the function itself? Okay, so some pretty basic things to begin with. If one x value is less than another x value, and our function is increasing, that means the y value is going to be less than the second y value. Right? If your function is increasing, let me draw a picture of this just for fun. Okay, so they're saying that there's some value x1, and that's less than some other value x2. Like maybe it's 1 in 45. Right? So if our function is increasing, that means the y value that goes along with x1 is less than the y value that goes along with x2. That's all that this is saying in some serious math speak. Okay, and then if we have a decreasing function, then of course that implies that the first thing, f of x1, is going to be greater than the y value of your second x value. Okay, and that would look like this. So if we had let's see, if this is f of x1 now, and then f of x2 is here, right now we have a decreasing function. Our y values are getting smaller. Okay, so this is how we formally write that we have an increasing or a decreasing function that's talking about the y values. Okay, if the y value in the first is less than the second one, then we have an increasing function, and vice versa. Now, let's get to the calculus. Okay, so here is our test to see if our function is increasing or decreasing. If our derivative is greater than 0, meaning it's a positive number, right? Everything greater than 0 is positive. Okay, if we have a positive first derivative, then your function is increasing. Okay, the y values of your original function are getting greater on the same interval, right? So our answers are going to be intervals between two x values, then your function is increasing. And then of course, if our derivative is less than 0 numbers are known as negative numbers. If that's true on our interval, then f is decreasing on that interval. Okay, on AB. Okay, so we're going to have a couple of parts in our answers. We're going to say what is happening. Is our function increasing or decreasing? Okay, on what is the interval that we're talking about, and then why. So these are your reasons why. These are your justifications, because your derivative is negative or your derivative is positive. So each of our answers are going to have 3 parts. Increasing or decreasing, what is the interval, and then is our derivative positive or negative. And then our third option, what if our derivative equals 0? Then our function is neither increasing nor decreasing. In fact, what we're going to find out is if our derivative is 0, that means we either have a local maximum or we have a local minimum, right? Because a derivative of 0 means we have a horizontal tangent line. And this is what we're going to call critical numbers. We're going to see where our derivative is 0, and those are going to be your critical numbers. Okay, so here's another first derivative test about critical numbers. So we're talking about maxes and minimums now. We're going to use the first derivative test to tell us whether we have a local maximum or a local minimum on a certain interval. So if our derivative changes from positive to negative, okay, we change from positive to negative. What type of a point is going to occur when we change from a positive increasing function to a decreasing function? The top of a hill is called a maximum. We're going to have a local maximum or a relative maximum, as you see right here, relative. So it might not be the absolute maximum, right? That's another test, but this is our thing that we can test to see if we even have a maximum. And then if our function changes from decreasing to increasing, or from negative to positive, okay, what's at the bottom of a valley? That would be a local minimum. Okay, so this is what we're going to use our quote-unquote first derivative test to find critical values. Do we have a maximum or a minimum? And it's all about whether our derivative changes signs at some particular point. Okay, let's apply that idea to finding this. So we have to do a lot of things. First it says find the intervals where f is increasing and decreasing. Okay, identify all the points that are maxes and mins, and then justify your answers. Okay, so justifying your answers is the calculus, or the AP part. Okay, and it's pretty easy to do. So let's just work through this example. So f is increasing or decreasing. That means we're taking the derivative, right? We want to see where the derivative is positive if it's increasing and negative for decreasing. Okay, so let's take the derivative first off. That should not be a problem. This is a polynomial. So we're going to apply the power rule to each of these functions. So 1/3 of x to the third. So we bring the 3 to the front. 3 times 1/3 is 1. So the derivative of 1/3 x cubed is just x squared. The derivative of x squared is 2x, and the derivative of 3x is 3. So we have a derivative function of x squared minus 2x minus 3. Okay? And we want to first find our critical points. So we want to set your derivative equal to 0. So we want to factor our quadratic. We're going to factor this. Okay, so what numbers multiply to give you -3 and add to give -2? -3 and +1. So our factors are x plus 1 and x minus 3. Okay, and Algebra 1 says we set each of our factors equal to 0. So x is -1. That's one of our critical values. And x equals +3. That's our other critical values. So what we do with these is now we're going to do a sign analysis. Okay, so we make our horizontal line, right? This is our number line. We put our critical values on here. -1 is a critical value, and +3. Those are the places where our derivative is 0. So notice we've created some intervals, right, in between our points. So we have an interval to the left of -1. We have an interval between -1 and +3. And we have an interval to the right of +3. So what we're going to do is pick any number you want to in that interval, and we're going to evaluate that. Well, evaluate it at that point. So let's pick some easy ones. Maybe we'll pick -2. Okay, that's on that interval. What's between -1 and 3? That's nice and easy. 0 or 1. Those are both good. Math with 0 is really easy, so let's pick 0. And then a number bigger than 3? 4. Perfect. Okay, so we are picking these values so that we can check to see whether our derivative is positive or negative at that particular point. Okay, so statistically speaking, we are picking one point out of this entire interval to test whether our number is positive or negative. And we're picking one number in this blue interval to test whether our value is positive or negative, and we're picking one number on this interval to represent the whole entire thing to test to see whether our values are positive or negative. Okay, so when I plug in -2, that's -2 squared minus 2 times -2 minus 3. So here are our evaluations. We get a positive 5 when we plug in -2. We get -3 when we plug in 0, and we get a positive 5 when we plug in 4. Okay, so let's do our analysis now, our calculus analysis. So on what interval is our function increasing? It's increasing where our derivative is positive, which is from negative infinity to -1, and then again from 3 to infinity. Okay, so let's use the correct calculus verbiage. Okay, so we're going to plagiarize. Plagiarize. It's okay to do in math. This is not English where you can plagiarize. So here are our 3 things. We need to answer the question. It's increasing, right? This is the what. What is it doing? Where is it doing it? Between negative infinity and -1, and then again from 3 to infinity, right? That's the where. And then why? Because our derivative is positive. So each of our answers needs to have those 3 parts. What is the function doing? Where is the function doing it? And why is the function doing it? So let's do the same thing for decreasing on its interval. So here's our parts. Our function is decreasing from -1 to 3 because our derivative is less than 0. So that answers the first part. Those are the intervals where our function is increasing and the intervals where our function is decreasing. Okay, so how do we know whether we have a maximum or minimum? And actually, what are those answers going to be? These answers are going to come from your critical points. Okay, your maxes and your mins are going to be your critical points, which in this case are -1 and +3. Okay, so at -1, what type of a point do we have? Our function was increasing to -1 and then decreasing after -1. So what type of a point happens when we go from increasing to decreasing? A maximum. So we write f of x has a local max at what x value? -1. Okay, we're only concerned about the x value. If we wanted to know the y, we could plug -1 into our original function and calculate it, right? But that's not what this is about. This is just about maxes and mins. So we have a local max at x equals -1 because f prime changes from positive to negative. Okay, we did all of the work for f prime, so we have to talk about f prime as part of our reason. And if our derivative changes from positive to negative, that means our function changed from increasing to decreasing. Right? And that's what our derivative of a local maximum was, or our definition. Okay, so we have a local max at +1, and what do we have at +3? A minimum, right? We have a local minimum for a similar reason. Okay, so this is what we have, right? Using our good calculus, we are saying what we're talking about, the function f of x, right? We're naming it. Has a what? Has a local minimum where at x equals 3 because our derivative changes from negative to positive. Okay, which meant that our function went from decreasing to increasing. Decreasing to increasing. So let's do a sketch then of our function using all of our knowledge. Okay, so basically we have our critical values on here. We have -1, something happens, and +3, something happens. So we're going to put -1 on here, and we're going to put +3 on here. And our function is increasing up to -1, so we're going to have a local maximum, right? I don't know what it is. I guess I could plug -1 into my function, and we could figure out exactly what that number is. But that's a thing for another day. And then at 3, we have another local minimum, right? So it has to be lower than our maximum. And then let's see, what do we know? We know our function is increasing, right? Increasing to the left, so it's coming, starts low, and then comes up to our maximum, right? Curves and goes back down to our minimum, and then continues going up. Okay. The fact of the matter is we don't know what the y values are. We did not calculate a single one of our y values. Okay? But we know it's a positive cubic, and all positive cubics look like this, right? They have a negative value. If you take a negative cubic, it's a really small value. So we know it has to come up somehow to -1. I didn't calculate the y value here, so I don't know exactly what the y value is, right? But I know it has to go back down to my minimum, and maybe my minimum's down here. I don't know. I haven't calculated it, right? I didn't plug 3 into my function and figure out exactly where that y value is, because we just want to sketch. So it has a maximum at -1, and it has a minimum at 3. Okay, we are increasing. Our function is increasing to -1. And then our y values are decreasing between -1 and 3. And then we're increasing again after 3. So there's a nice sketch of your function that happens to be a cubic function. Okay, so those are what our derivative tests tell you, where our function is increasing and decreasing, which helps us to find our relative maximums and relative minimums.